let's talk about how you calculate the cross product. Now, the cross product, focus my friends, here we go. Cross product only exists on three-dimensional vectors. There is not a cross product for two-dimensional vectors, just for the record. Now, this is obviously why you're always going to have the formula. Clearly, the lovely little x there is your cross product. And this is why I say even I always double check on the formula sheet, because look at how, like it's kind of random how they have all these paired up to do your cross product. You've got A2, B3 minus A3, B2. And then it goes A3, B1. I mean, you just have to follow the coordinates, the components of the vector, and use the formula. It's easy, you just have to make sure you're looking very closely and following that exact formula. One other thing too to point out, because we've done dot product, not to confuse the two, dot product and cross product. Cross product, you get a vector. So we'll actually get a vector answer today. And most of the time I'll write it in component form, unless it specifically asks for the I, J, K style. And like I said, it's only on your three-dimensional vectors. We've already talked about that. And one of the reasons or purpose or uses of the cross product, it's orthogonal or perpendicular. It's perpendicular to both vectors. So that is why we also want to use our cross product. So, okay, here we go. We're going to calculate the cross product. Get ready, my friends. So you've got your vectors. I'm just going to label them, of course, A1, A2, A3. And it's really just plugging the numbers into the formula. B1, B2, B3. And you can see I've got the formula in front of us for a reason. Okay, so find the cross product. And here we go, A2, B3. So -1 times -1 minus A3, B2. So 3 times 0. Now, I know you can do some of these calculations in your head clearly. Just for the first one, I'm going to write it all out for, dramatic emphasis. All right, so I'm in the middle here, A3, B1, so 3 times 2. And then minus A1, B3, 0 times -1. All right, and we're on the home stretch here. I'm running out of room. A1, B2, so 0 times 0. I'm going to sneak the bottom ones underneath here. A2, B1. So -1 times 2. Okay, pretend, I don't think it's going to be off the screen there, kind of my component at the end. So now we just got to clean it up and do all the calculations. So -1 times -1, 1 minus 0. And remember, your answer is a vector, of course. We're crushing it here. 6 minus 0. 0 minus -2. Got it. So it's not difficult, obviously, if you're provided the formula. You just have to make sure you're, watching that formula closely. And obviously, I like to work generally in this component form style, but if it asks you to write it with the I, J, and K, of course, you might have to write it I plus 6J plus 2K. Just to throw that on as a little, I don't care what style, it doesn't ask you for a specific style. I generally will go with the component form style, what I have circled, but just if it asks you, I threw it on there. Okay, ready for using the cross product now. Here we go. So cross product, of course, we already talked about this on the previous formulas. It is, I just used the word orthogonal to fancy it up here, perpendicular to both of our vectors. So find a unit vector that's orthogonal to the plane containing these vectors. So I'm going to show you the unit part of it in a minute, but let's just focus on this orthogonal. We know we need the cross product. So I'm going to calculate, just like we did before, the cross product. Now, this is just me. I don't like it in the IJK style. I'd rather have it component style. So first I'm just going to rewrite this. Well, you have 0I, -1J, 3K. And then I'm going to rewrite D in the component style, because that's just how I like it. So 2I, 0, -1. All right, so we're going to do our cross product. You are going to be using your very lovely formula here. Have it on your sheet. I don't have it on the slide. Look off your sheet. I, of course, am going to label these. A1, A2, A3, B1, B2. Got it? Okay, let me give you a minute to try the formula. Let's make sure you can plug everything in and get me the very lovely cross product. Or, I did this on purpose to save us some time, you'll see. Isn't it the same as the previous one we did? Okay, and that's on purpose just to save us some time, because you'll see I did that on another one too. So I'm going to use the 162 from above. Just recognize they were the same. And because I can't help myself, I feel like I should put a note. We got that from example 1. So that's the part of it that makes it quote-unquote orthogonal. Okay, here's the tricky part. Well, I shouldn't say tricky, but the extra work we have to do. It wants that unit vector. So now to make a unit vector out of it, we also need to use the magnitude of it. So the next thing I'm going to do is calculate the magnitude of our cross product. Which we can do that, that's easy enough. I'm going to have my 1 squared, 6 squared, 2 squared. Okay, total that up for me. What do you got? Square root of 41. I'm happy that that is prime, of course, because we don't have to worry about simplifying. So to make your final answer, your unit vector out of this, all you have to do, the cross product, of course, makes it perpendicular, orthogonal. Then if you divide it by the magnitude, divide each of those by your magnitude, that makes it a unit vector. So this, I'm going to have to simplify. It's going to be gross. Because I'm going to have 1 over the square root of 41, which you know I'm going to rationalize that in a minute. I'm going to have 6 over the square root of 41. And then I'm going to have 2 over the square root of 41. And then, of course, my final answer is just the rationalized, simplified versions of these. So square root of 41 over 41. 6 square roots of 41 over 41. This is gross. And then 2 square roots of 41 over 41. So that is the unit vector. So if it just says orthogonal, you just have to do the red, the cross product. To get it into that unit vector, you have to divide it by the length. That's as wild as it's going to get today. Any questions on that? All right, flip it. Let's do some more. Here we go. More cross product. I'm so happy. So happy. Love cross product. Okay, find a vector perpendicular. So right away I'm like, oh, gosh, perpendicular. Okay, here we go. I'm going to have to do cross product again. Okay, but if you take a look, you've got the 3 points there. Well, for me to do the cross product, I need vectors. So first thing I'm going to do is take those points, and I'm going to convert them into component vector form. Now remember, to do the cross product, we need 2 vectors. You have a starting point P on these. One of the vectors is going to be P to Q. My other vector is going to then be P to R. And I'm going to do the cross product of those. So the first one I'm going to do is P to Q. And again, this is just nothing crazy. We're just going to compare ordered pairs. So from 1 to -2, clearly you went down how many? Keep going. From 4 to 5, you went up 1. And then from 6 to -1, you went down 7. Got it. Now I'm going to do the same thing because we want to start at that same point and make our 2 vectors going from that same point. So I'm going to do from P to R. I said P. I can't write and talk here at the same time. P to R. Okay, so make your vector from P to R. So from 1 to 1, what do you got? 0. From 4 to -1, you went down how many? 5. And then again, 6 to 1, you went down 5. So little extra work on this one, we had to make the vectors. Not that that's that hard, but we had to do it. Now, to make it actual, to get our final answer, perpendicular, we have to do, look at your formula sheet, the cross product of these. All right, so I'm going to start labeling A1, A2, A3. So, of course, it's on your formula sheet. Follow the formula sheet. Now you're just doing the cross product values off the formula sheet. So let me give you a minute. Let's see how your cross product knowledge is. You get, I should say, the first number is kind of big. Not horrible. See what you get. Let's test your cross product skill. Second. negative 15, 30, 15. Got it. So this is just, you know, thinking about your quiz too tomorrow, thinking about directions. It just asked us to find a perpendicular vector. If it asks me for the magnitude, then I do the square root of each of those squared and add them together. If it asks for the unit vector perpendicular, then I have to divide each of those by the magnitude like we did on the last one. But it doesn't ask for it on this one, so I'm not going to worry about it. We're just going to move on with our lives. Okay, more cross product. I love cross product. Sarcasm. So length of the cross product. Now we know the length is the magnitude, but sometimes they don't necessarily give you all of the three components for each vector. We can still calculate it, and that's this formula. They might give you the angle in between the vectors. So if theta is the angle between your two vectors, and they're between 0 and pi, catch that little note there. So another way you can do the magnitude of the cross product, if you have the angle and you don't have the three components, the three different values in each vector. Magnitude of u, that's really times, of course, between them, times the magnitude of e times the sine of theta. And of course, just catch this, if your cross product is 0, they are parallel. Very exciting, I know. Okay, let's try it. So here you can see, you don't have the three components for u, you don't have the three components for v, which makes me really happy because then I don't have to do that long crazy formula. We can still do the length of the cross product, okay? So to do the length of the cross product, so I'm just using the formula up there. Magnitude of u, which they gave us, which was nice, times the magnitude of v, which they gave us, times the sine of 30 degrees. Okay, all right. Well, we all know 4 times sine is 20. Let's see, how good are we? What's the sine of 30 degrees? 1/2. And a final answer for our length of the cross product, a big whopping 10. I like that formula. I like it. All right, I feel like I'm kind of teaching geometry now. Coming up to, we're going to start with parallelograms before we get to the next thing. So parallelograms, you can also use vectors to calculate the area of a parallelogram. So the, catch it, length, so we're going to do the length of your cross product, well, cross product is the area of your parallelogram. And you can kind of see over here on the picture, you don't really think about this in geometry obviously, but you can use your two vectors on the corner there, or the side of the parallelogram. You can think of it as two vectors on it, and the area of that, of course, is the length of the cross product. Now, they want you, fancy here, triangle. Well, we love geometry in here. We're not going to sweat it. We know that a triangle is half of a parallelogram. So I'm going to do the area of the parallelogram and just cut that answer in half and be done. Now, notice I gave you points. We need vectors. Okay, we can do vectors. Now, same thing. We're going to go a vector from P to Q, because we want to start them at the same point like they are over here in red, and then we're going to write a vector from P to R. So what's your vector P to Q? Start with that. From 1 to -2. Got it. Does this look familiar? From 4 to 5. It's on purpose to save us some work. From 6 to 1. Okay. And again, this is on purpose just to save us some time. Hopefully this looks familiar. All right, what do you got for P to R? P to R, 1 to 1. 0. What do you have from 4 to -1? And what do you have from 6 to 1? Okay. So first off, any questions on our very lovely vectors? Okay, next up, here's the gross part. I don't know why, I just find it time consuming. So remember, to do the area, it's the cross product and then the length of that. Well, let's just do the cross product first. Or I'm gonna say you're gonna do the cross product. I'll label for you. All right, take a minute, use your cross product formula, see what you get. -15 and 15, got it. Okay, so then your final answer, we're 2 steps away. This is, to me, easy, but just time consuming, all the calculations. The length of it. So now you've got to do the magnitude. Now, here's the thing, it's dealer's choice here, people. Does it say in the directions we have to give an exact answer anywhere? Okay, so we can use a decimal if you want. If you want to just punch it all in the old calculadora, crank out a decimal for me. You can, you can. And we're almost done with this. What do you got? 36.7. Carter has agreed. Not quite done, we're almost done. I have the exact answer version. I say we're almost done. That would be the area of the parallelogram. We want triangle. How does a triangle relate to the parallelogram? It's half. Final answer. 18.4. And again, I mean, it's still easy, but just read closely. If it wanted the parallelogram, I would have gave the 36.7. It wanted triangle, so I had to use my geometry knowledge that it's half of it. Okay, easy stuff, just time consuming to do the cross product. All right, last thing I have for you. I feel like it's more geometry again. Okay, however you want to pronounce this. Actually, I think Caitlin pronounces it better than I do. We're going to talk about the volume of the, I like it, parallelepiped. We're going to go with. However you want to say that. Okay. Okay, so notice it's like a parallelogram up here in the picture, but it is a three-dimensional figure. So we're going to calculate how much you could put inside this parallelepiped. Okay? So that's what we're going to do. You've got the formula here. Let me just explain the formula to you. But again, it's easy. It's just a lot of calculations. This is what we call, of course, using, this is just for fun, the scalar triple product is what, okay. Okay, so you're going to do the cross product, which I already cringe at, all that A3, V1, okay. We're going to do that, and then we're going to do the dot product of it with you. So it's easy, but a lot of calculations. If the volume of it is 0, just for fun here, just so you know, then the vectors, of course, are coplanar. So if it asks you to, it might ask you, hey, are these vectors coplanar? You would be doing your scalar triple product. You would be calculating this to see if you get 0 or not. If I want the volume, I'm calculating that scalar triple product. It's easy, you got the formula. It's just time consuming for all the calculation. So show that the vectors are coplanar. Okay, all right. So first up, I'm just using this formula. I would start with the cross product. So we're going to do V cross W. Let's start with that. So remember, cross product is a vector. So careful, you were using V and W. So look at your cross product formula again, and calculate your cross product for those two vectors. With it, I see a lot of perfect answers. Let's just fill them in here. Negative 36 and negative 18, right? Okay, now, we're still going, people. We're still going. So on your formula, we just did the cross product part. Now, switch your brain. We haven't done this yet today. This is good review for your quiz. We're going to do the dot product with u. Okay, so I'm going to write down u here, 1, 4, negative 7. And we're going to do the dot product with our green answer here. Now, remember, your dot product is just a single numerical answer. We have done dot product on 2-dimensional vectors and 3-dimensional vectors. Good review for your quiz. This is easy. To do dot product, you're going to do 1 times 18 plus 4 times negative 36. You can see I got to look at it. I can't remember what that is. What's 4 times negative 36? And then negative 7 times negative 18. Total it. Okay. Now, just for the thrill of knowledge here, I mean, we're at 0, so that makes our lives pretty easy. So it says show that they're coplanar. Well, remember they're coplanar. I gotta scroll it, it's off the screen here. They're coplanar, of course, if the volume, if this equation turns out to be 0. Now, technically, for the love of math here, If it's not 0, if we're not doing coplanar, if they just want the volume, don't forget to, focus Parker, if you don't have 0, because it's 0, I mean, you square root 0, it's 0, who cares, I'd be done with it. But if you had a numerical answer and they want the volume of the parallelepiped, you would do the magnitude of it. I mean, this time it's not really worth it. The magnitude, I can't write and talk. We would do the square root of 0 squared, which of course is 0. But just if it was a different number, like 15, you would still have to do that magnitude on it to get the actual volume. We just have 0, which is super, super easy, so I'm not too worried about it, okay? But the fact we got 0 shows that it's coplanar. So questions on that? All right, isn't that fun? That's so fun, the cross product.